Well, good morning. At least it's good morning here in California. Jack, I believe it's early afternoon there in Boston. My name is David Laws. I'm semiconductor curator at the Computer History Museum in Mountain View, California. And it is April 27th, 2021. So we are still a year into the great pandemic that's been sweeping the country. And this will be one of the first oral histories that I have done via teleconference with Jack. And Jack is at his home in Brooklyn, just outside Boston. And Jack has a long and interesting career in the electronics industry as an electronic engineer. But also he has started many years ago, and we'll talk about this later in the interview, his own semiconductor museum, and has collected a considerable amount of interesting information and documents from the early days of the semiconductor business. And Jack also has been extraordinarily generous with sharing some of his work with the Computer History Museum and providing documents and devices for the collection. So welcome, Jack. Good to talk to you. Good to see you. And perhaps we could start off with you telling me a little bit about your background. Where were you born? Where were you raised? And tell me about those early years.
Good to talk to you again, David. I miss our somewhat infrequent but in-person interactions that we had prior to COVID. So. Yes, I'll be happy to do some background discussion. I'm a boomer, as they say. Was born in '49, and curiously enough, that's approximately the same time, within a year or two, when the transistor was invented. So I don't know if the stars were aligned or exactly what. But I grew up in the South, rural South, and did not have much contact with technology for a number of years. I left the South in my teenage years and moved up to Illinois, outside Chicago. So that was a shock in a number of ways. But I remember my long summer days in the South growing up, and at that time, maybe we'll get into this, my father, who worked for the U.S. Air Force, was supplying me with salvage early transistor devices. And these would be boards that would be covered with thick shellac and, military grade at the time, just gleaming with transistors, or I would get old junker radios and take them apart. So I just have many good recollections in the South growing up with 100-degree temperature and very humid and not much going on, except me sitting in front of a fan with a huge soldering iron trying to connect up some transistors. So
you're obviously fascinated with the electronics, but also this access to radio must have opened a whole different world to you than was just outside your front door.
It did, actually, and I guess you would call me a hobbyist at that time. And I remember getting my first shortwave tube radio, 2 tubes, a regen set made by Nightkit, Allied Radio. And I looped this really long wire up around the house, and I would sit at night pulling in unbelievable transmissions from across the world, with this little tiny 2-tube set, with messing around with the regen knob and getting all that squealing going on. It was a real eye-opener, and I think that kind of set the stage for a broader set of interests that I developed. But those are really fond memories.
Were you able to share this interest with other kids in the area or relatives, or was it pretty much alone?
Yeah, it was pretty much alone, actually. That's not such a problem when you're 10 years old. You had other interests in sports, fishing in the swamp, for instance, or chasing alligators, that kind of stuff that you do when you grow up in the South. But really, other than my father, there was really no one who had an interest in electronics.
Kind of different world from Brooklyn, Massachusetts, huh?
Yeah, no kidding. Totally different. But, the whole world's changed. It's hard to think. That was a long time ago.
Yes, it was. You mentioned your father's background. What did your mother do?
Well, curiously enough, my mother was, I guess I would call her an entrepreneur, which in that time, in that place, meant that she had some business acumen. And so she had started a few businesses, various kinds of service industries, and maybe hotel management, all based on her own, go-gettedness, I guess the way to say it, her own motivation and drive. There clearly were very few role models. And so I was impressed, have always been, with what she did. She didn't go to college. My father didn't go to college. And so, in fact, no one in my family went to college. But, pretty good role model, both from her with her focus on business and, getting stuff done, and my father's exposure to the world of high tech through the Air Force.
Sure. Any brothers or sisters?
Yes, much younger, and so not much in the picture, and delightful additions to the family that I enjoyed very much, but really not involved in the electronics at all.
How about school? Did you enjoy school? What was your focus there?
I did actually enjoy school. I think I don't know if the term nerd was around at the time. Maybe it was. I'm not sure. But I did enjoy school. I don't think obsessively so. Again, kind of understand the level of instruction and the topics that were available in mid-1950s Mississippi. You can imagine there's not a real focus on high tech at the time, although that's changed. But I did, yes. I like to read. I read a lot. Boy, I sure would have enjoyed the internet back then, but I guess that's not a possibility, huh?
Well, you had your own international internet through the radio, I guess. That's about as close as it came.
It's true, David, when you think about it. That was a real connection to the rest of the world, and it was amazing to me. I think maybe one of the topics we'll talk about is the rapid acceleration of technology and impact on folks, but without that radio, I don't know what would have happened, to be honest with you. Who knows?
It sounds like your father was the major instigator of your interest in this direction. Can you tell me a bit more about him? What did he do? We know he was in the Air Force. What was his role?
Yeah, so I think that was his way to be involved in technology and expanding his horizons, joining Air Force at an early age. And he was initially a jet plane mechanic stationed out of Biloxi, with a big Air Force base there. And so, he had been an auto mechanic at home, had his own shop, worked in a shop. So he was mechanically inclined and got really good training in the Air Force with jet engine repair. And then somehow or another, he made the transition from that to electronics repair. So I have come across on eBay over the years some of these mid-1950s Air Force training manuals that take you from tube electronics to solid state. And although I didn't have any that he used, I'm sure he was sitting there with rapt attention, looking at here's what tubes do and here's what solid state does. So there's a connection I made with him in that regard. So he moved up. He became kind of a supervisor in electronic repair, by that point mostly all solid state, towards the late 50s, and then became an instructor for an Air Force training school for repair for electronics. And he kept pumping me parts and books and interest. It would buy me stuff, for Christmas, things like that radio I talked about, or every young man's delight, a 50-pound battery that'll last for 5 years that you can use to power all your stuff or fry all your stuff if you hook it up wrong, for example. So I remember that quite fondly, and that did help me. And I do remember getting a gift from him at the transition from U.S. electronics supremacy in radios to when the Japanese radios were coming on in the mid-60s. I remember getting a really cool, slick, highly artistic, turquoise blue Marvel, M-A-R-V-E-L, 6-transistor radio from Japan. That was about as good as it got.
Yep. I can imagine. It sounds like he was extraordinary influence, and you were very lucky to have that support in your direction.
Yeah,
Now,
yeah.
from your school, you went to college, I understand, and this was way out of Mississippi. Why that? Why the move?
Yeah, so I went to college at University of Illinois, which is right outside Chicago, about 100 miles. And I ended up there because my father was stationed at a huge Air Force base in that area. So that was a pretty good draw and lead in. So I still remember the film that I saw, the training film, when I enrolled in electrical engineering. Hey, that was going to be the path, right? And this would have been in the late 60s, and so I remember the orientation. There was a video, probably 16 millimeter or 32, and Technicolor, showing the end point of the career with about 50 engineers, all men, all clean cut, white shirts, pocket protectors, over a drafting board, if you can imagine.
Yes, I can. I saw the realities of that too from that era. What did you study in college?
Well, I lasted about a year and a half in engineering, electrical engineering. I did okay, but my heart wasn't in it. And so there was a lot going on in the world back then in terms of counterculture. So my interest drifted over to motorcycles, rock music, and anthropology. That seemed like a pretty cool thing to study. So I got my degree in social anthropology and linguistics.
Very 1960s.
Thank you. Yes, it was. And I don't regret that at all because of the way things turned out. But I'm just wondering where I would be today had I stayed in that original role and been one of those engineers with my drafting board.
Who knows? Who knows? The turns and twists we take along the way that you look back upon.
Yeah.
So you graduated with a degree in anthropology. I doubt if there were too many places you could go apply that skill. Jack, what did you do?
Well, reality sets in at some point. So I had my motorcycle youth, I guess I'll say it that way, traveling the country and outside for a while, and then decided to settle down. In college, I had an internship doing photography. So I did a lot of work for the university. And at that time, the computer center there at University of Illinois was pretty well known worldwide. It may still be. And I left before Bardeen showed up, and I didn't actually, not even plugged into that at all. But I remember the iliac and taking some pictures of the iliac and some of the circuitry, and it, of course, didn't dawn on me at the time what I was doing. I was also taking pictures of Indian pot shards that were being dug up from a local dig. But nonetheless, that was kind of an initial exposure. But I had a couple of years of highly memorable adventures, I'll say it that way. And then decided that I probably needed to settle down at some point.
Did you read, was it Zen and the Art of Motorcycle Maintenance was around about that time?
You've been there, David. I can tell. I can tell a kindred spirit, man.
That's for sure. Interesting times. Yeah, I arrived in the United States in 1968, walked into Silicon Valley at the height of the Berkeley free speech movement, and a fascinating contrast on different sides of the bay. The techies on the west and the social radicals on the east.
Yeah.
And somehow it all melded together over the years.
Somehow it did, but I'm with you on that. It was amazing to see all, and you're trying to pick your career path and what interests you. It's really hard to know. So reality often helps. I really needed a job, and ended up in Ann Arbor, of course, with the University of Michigan. And at that time, they were spinning off high-tech companies like most universities. And so I answered a newspaper ad and became the production supervisor for a small startup that was making discrete semiconductor boards, 10 by 12 PC boards, all discrete. No, maybe a couple of the first TTL ICs, but mostly discrete transistors. And these were all peripheral to a Data General Nova 16-bit computer with a paper tape reader and my favorite paper tape punch for I/O, and a screen, and it was a text editor. That was the purpose of it, and it would output the appropriate controls that you could take the paper tape and load it into a typesetting machine at a newspaper. So a real niche. They did all the software, which I didn't really get involved in very much, but they designed all their I/O stuff to interface around the 1200, the Nova 1200. So that was real eye-opening. I did the production stuff and helped some with production engineering. It was a really small company. So that kind of got me hooked on, I guess you'd call that the mini computer boom. I guess that's a good way to say it. Wouldn't you agree?
Yeah, I was at Fairchild again in the early days of Data General, and I remember they were desperately wanting short parts that were in great shortage, and we were busy supplying them to Burroughs and IBM and NCR and all the big companies. And there was this little company, Data General, that it turned out a couple of the Fairchild executives had invested money in, so they get more than their fair share of chips at a time of shortage. So I'm glad it maybe helped your career in a little way from that. And so where did this learning experience lead you to?
Well, at the time, I had to do troubleshooting of the Data General and the peripherals. And I guess because my linguistics background was still inkling in my back of my ear, I took a part-time job along with this job with a tech writer, a local tech writer, who was developing troubleshooting service manuals for Data General. And so, you know, it's a matter of looking at a schematic, really simplistic schematics with the tops of maybe 10 transistors, right, and explaining the operation. So I really liked that. And at about the same time, Data General was expanding. They were really high spurt growth. You know, they were cheaper than DEC and pretty powerful. So I answered an ad for Data General they were starting up a service repair training depot. So I kind of built on my background servicing Data General stuff and tech writing, and worked for a couple of years training Data General service technicians. That then led to, I guess it would be a promotion looking at servicing support for software. So I learned their operating systems and would be the guy that somebody would call when there was a software problem. So I was really happy. I can't complain at all. That was, again, real high-tech growth. And I know you've been out here, David. You drive up Route 128, and not that many years ago, that was the place to be. Everybody was there.
Yeah, I remember spent many hours in the old mill at Maynard trying to sell stuff to DEC.
Yeah, yeah.
And then I remember meeting with Dick Soggy out at Data General when we were trying to decide whether we should build Schottky TTL or not at Fairchild.
How about
that decision?
Yeah, wow.
Small world, isn't it?
Yeah, it is an incredibly small world. So I can go on a little bit.
Yep, sorry, carry on with the story about how you actually joined Data General, right?
Yeah, I did, and I was working for them for, I think, maybe 3 years. But I think the big breakthrough for me, career-wise and professionally and everything else, was joining Hewlett-Packard. What a difference. And at that time, you know, HP was building their own mini computer line. Remember the Spark RISC architecture? And so I got into that because they wanted somebody who knew mini computers. But their sole focus here was medical devices.
That was up in Waltham.
Yeah, correct. Exactly right. It's been taken over by, I don't know who, somebody, but they're long gone. I spent many years, 20 years with HP. What a phenomenal place to work. I met both Packard and Hewlett, John Young when he was working on, and it was just an eye-opener to see how a real company could be run, how people were treated. They had at that time a whole resort area with cabins down on Cape Cod that they had bought for their employees. And so during the summer, you could sign up for getting a week to take your family down there. It was just unbelievable how well you were treated.
And it was a time of great transition for HP as well, growing dramatically in the mini computer business, their 3000 series computers, and then, of course, into the printer era. Mm-hmm. Were you aware of a lot of the politics that were going on the West Coast?
Not so much. I was pretty much isolated. The medical products group, which is what I was a part of, really kind of had a life of its own. Because of the FDA regulations and requirements. And to be honest, we were kind of used as an example about how to do rigor in software design, rigor in hardware design. So we got a chance. That was, in addition to seeing the HP way, I got to see Galactic headquarters there on Page Mill Road. And I used to love taking my business trips out to Palo Alto when it was 27 below zero in Boston and it was springtime. I just used to love going out there, made a lot of friends, and had I known what I know now with that time, with everything going on in, with Shockley, with Fairchild, with Rheem, Signetics, I sure would have made a better use of that time, but, you just never know.
Well, it sounds like you put it to good use personally. So, did you ever come across Bill Kemp? Bill was involved high-level quality control at HP, was there for about 50 years.
The name sounds very familiar to me, actually.
He's a neighbor of mine just down the street here in Pacific Grove. He actually served as mayor for the last 4 years or so, and he is on my list to do oral history of sometime down the road. So I'll let you know when that happens. You might see a familiar face.
That would be great. And I'm not sure I worked with him, but HP, as you know, at that time really focused on quality. And quality not at the expense of other stuff, but had such a phenomenal reputation. And that was really formative for me to be with that company. I guess people say that same thing now about working for Facebook, I guess, or for other companies about how it's so formative. And 20 years is a long time to spend with a company, but I have no regrets about that.
Sure. What were the real lessons you think you learned at HP that you've applied later in your life, both personally and in business?
I think how people are treated, and it was with respect. People really wanted to work at HP, and it's because you really felt part of a team. You may remember this management by objective or management by walking around. Yeah, that's the one, and it was really true. No micromanagement. No weirdness from your supervisors about do it this way. And the higher up you got in the organization, the more you felt empowered to make change because it was the objectives that you were seeking to accomplish, but doing it in a way that treated people well. I'm idealizing a little bit, but not bad. I mean, it was amazing to me. So I think just that style of management and the technology was super cool. I got a chance in various. This was, I did a lot of software development there too, and this was before DOS even. This was, a lot of machine code, assembly code, firmware, and so just getting some interest in that whole process, I think, really shaped my interest, continuing interest in technology.
And how long? You said 20 years. When did you leave HP, and what was the motivation?
Yeah, it's curious. So. HP during the dot-com boom and bust in 2000 decided to spin off the medical products group because it didn't fit neatly into the other buckets that you were talking about, printers, computers, test instruments. So the spin-off happened, and Agilent was one of those spin-offs as well. And Agilent took all the kind of the traditional HP business, test and measurement.
The real HP is.
Thank you. That's the word, yes. And I remember going out working with them for a while. They took the medical products group and then said, this doesn't really fit into our notion of traditional HP. So they sold the medical business to one of the three large worldwide medical device companies, and that's Philips.
Yes, sure.
Mm-hmm. So that was a big transition, and it seemed like a good time for me to, my kids were pretty much grown at the time. So fortuitously, there was a lot of work just again by happenstance relating to semiconductor work in the Bay Area. And there were some startups that were using kind of really basic semiconductor technologies to build medical products, specifically gene chips. So I went to work for Affymetrix, Santa Clara. Loved that place. What a change to go from a large but nice company in Massachusetts to a foot to the floor accelerator in Santa Clara.
So you physically moved yourself, your wife, family?
I did not actually.
Oh.
Because of my exposure to the FDA and ability to work with the FDA at that point, I was able to do remote.
Interesting.
Yeah, there was a small group out here that I actually had an office in, and I worked with them, but it was primarily through the Santa Clara or Mountain View facility. So I made many trips out there again, and just driving again, thinking about all the plaques that have been put up and the recognition for Shockley transistor and all that. I was just driving right by and still didn't have an interest in that area, but I really liked California.
Can you tell me a little about the technology of the gene chip? I don't spend a lot of time on it, but I don't think it's anything we've really ever covered here at the museum.
I've been thinking about that too, although it's not in the strictest sense of the word, it's not a transistor, or it's not a semiconductor, but the methodology is this. C, G, T, and A are the basic building blocks of all DNA, and those are chemicals. And so in a manufacturing process, you can buy bulks of those chemicals, and then you could use a inkjet printer technology, for example, to spot and sputter depositions of those chemicals onto say a microscope slide. And so it was not leading edge technology for semiconductor manufacture, but it was not bad. Over the course of 3 or 4 years, as the density of semiconductors increased, Moore's law, for example, some of that out-of-date equipment could be used for these lesser dense applications like gene chips. I think Agilent got into business for a while using that same technology. So in the amount of time that I was there, the human genome was decoded. And so once that sequence is understood and decoded, you can use that as a map for building layers, structures of C, G, T, and A droplets onto a glass slide. And so in the end, I think probably, I'm trying to figure out the dates, maybe in the mid-2000s, 2005 or 6, after the human genome was decoded, Affy and a few others, Affy was the leader, was able to deposit the entire human genome on one chip. And the way it's used then is that if you take a tumor sample, cancer, tumor, and process it in a certain way, it will bind to the appropriate receptor pattern that you've laid down on the chip. So by knowing the location of where you've put these synthetic DNA patterns on the chip, you can determine which areas the cancer tissue sample is binding. And then you use fluorescence to make a visual map of the chip. Things have progressed quite a bit since then, but nonetheless, that's the basic technology in use today. There are ways to use this kind of really elementary semiconductor manufacturing technology to make ever more complex and increasingly complex genetic patterns on chips. All species, for example, when you send in you want to get your dog typed, what kind of dog do I have? So I think this is still true. That would be a massive chip with many dog species on it, or dog varieties, right? And so you could determine then by putting the sample on. Those chips are still in use. They're much more complex now, but what an eye-opener that was, I'll tell you.
can imagine. And your role for the company was largely with interaction with the FDA and regulation and
That's right.
documentation of
That's right.
the process and how it's
Yeah,
applied.
yeah. I was able to use my engineering background as well, because you have to translate kind of novel, unfolding engineering concepts to a government agency that's wanting to fit that into the existing regulation. So it's highly interesting, actually. I enjoyed it.
And how long did you spend with Affymetrix?
Around 10 years. Many trips out to good old Santa Clara and Mountain View. I drive up. I got a pretty good path down. I would usually stay up in the city. I have relatives up in the city. So I figured out 280 is a much better way to go than 101 in the morning. So I would take 280 down to either 85 or something like that.
85, take you across, sure. Yeah.
That's it. Yeah.
Now, you'd have passed my house many times. I lived in Portola Valley, just off behind Stanford.
I know exactly where that is. It's a nice place
Alpine Road exit, and yeah, it's a lovely area to live.
Very cool.
So then after 10 years, you decided to start your own business?
Yes, indeed. Things evolving so fast. You reach a certain point in your career, you say, what do I want to do? And I was, at that point, through working in that technology, I developed pretty good skill set to work with other companies who needed FDA support. So it seemed to be a pretty reasonable fit. So yes, I started my own consulting company and traveled the world, right? Saw a lot of stuff, saw some really interesting technologies. I didn't like being a road warrior at some point. You rack up, you must have had the same thing happen with you in Fairchild with your travels.
Sure.
But I still have it. I actually have 2 sons that I brought into my business. I'm trying to extricate myself as quickly as possible to focus on more semiconductor history and let them provide me a stipend on a monthly basis.
And so still a consulting, not actually designing and building anything?
Consulting, absolutely. I do design and build circuitry from the 1950s. So I do that, but that's unrelated to my business.
Sure. And I understand that's kept you pretty busy through the recent pandemic in the last year. How does that relate to what's been going on in the big wide world?
It's really interesting. I have not been too philosophical about this. I'm grateful that I'm able to continue doing this consulting, largely because it helps my family. There are a lot of people in the world these days who are having a really hard time getting a job or knowing what they want to do. And so I've been incredibly grateful to be in this situation. And it seems like, I'm sure it's true for other industries as well, but medical device industry is in an unbelievable growth spurt and has been, for the past 10 years. And the pandemic, in my opinion, did not slow it down. It actually cranked it up.
Yeah, explosion in all aspects of life sciences.
It's amazing to me. And I think one of those aspects has to do with technology. So now there are even further elaborations on diagnosis technologies. Say, for instance, taking a small sample of blood and then using a variety of genetic techniques and others to make a large number of diagnosis decisions based on that small amount of blood. And there are many companies doing that, and it's a race. You have to use supercomputers, use artificial intelligence. It goes into machine learning. There are advanced techniques for pulling out the appropriate parts of the blood that can then be amplified through chemical and biological processing. It's just unbelievable what that field going on. And say if you look at pathology, for instance, there are several companies who are moving ahead to take a look at a tissue sample slide, and make a diagnosis based on AI, no human involved. Just kind of hurts my brain to think about that. But the FDA is trying to catch up with that.
Sure. It's a little ironic that probably most people in Silicon Valley know about a lot of this work because of the disaster at Theranos and the work that was supposed to be being done there.
Right.
Sounds like there's a lot of real work being done in the area they were attempting to pioneer.
Correct, and that's the case, and there are major breakthroughs in the offing that, in fact, are based on science.
And you're continuing to do this today?
Indeed, I had to cut one of my earlier sessions off because you guys were my favorite today. I do training as well, training for companies that want to catch up on this. So I think I have a grand plan. Everything comes together, and Jack's able to. I don't feel good about not spending more time with my museum, and I'm trying to rectify that.
Sure. And we skipped over that because I wanted to follow the career path. So now let's back up. Understand that you started getting into this. I read that wonderful IEEE Spectrum article many years ago when I first wanted to find out who you are and how you got involved with the CK722, I believe. Tell me about what happened there and how did the whole thing grow?
You know, it's hard to, in retrospect, to look back. This was in the mid-90s, and I was still at HP, Hewlett-Packard, so pretty mature in my career path there. So I wasn't working 80-hour weeks like a lot of people do these days. So I had a little time, and I started, everything. That seems like ancient history now, and I hate to say that, but it does seem like it. The internet was just becoming more or less available. I got my AOL address at the time, transistormuseum@aol.com. Now, I got to tell you, I've kept that same email address since '96. And when I get comments, and I do, and all usually in good fun, good nature, about, you have an AOL address, I point out that oftentimes the person making that comment wasn't born at the time that I got that AOL address. And so I guess I'm ranting like an older guy right now, but there was a lot happening then, and on a positive side, I was able to take advantage of the internet at that time. eBay was just coming online. You could buy a digital camera for taking photos of these things. eBay was still small enough that there were lots of swap meets, Hamfest. So I acquired, for a song and a dance, lots of stuff that was going for the landfill. And I wish I could have done more, but
why did you do that? What was it that attracted you to the pursuit of this area?
I think I really wanted to come up to speed with internet technology. I wanted to build my own website, which I did.
Okay.
And so I was looking for a cause. And I had been going to some of these Hamfest, swap meets and stuff. So it just kind of seemed to click. I don't know exactly why, but it seemed like a reasonable topic. When, it's electronics. I had experience with electronics. There seemed to be an ongoing expertise for vacuum tubes. There were many websites or many books or a lot of clubs that focused on vacuum tube history. But there was nothing going on that I could tell with semiconductors in terms of historical understanding and preservation. So I can't put my finger on exactly one thing, but everything kind of came together, and what really launched it was at one of these, I got a circuit board with germanium transistors for a Nike Zeus missile at one of these Hamfest for $12.50. I still have it. Can you believe that? It's just mind-boggling. But in any case, I happened to meet somebody there who, I don't know what we started talking about, but he said, Raytheon has a semiconductor historian. I said, oh, I never knew there was such a thing. I knew about Raytheon. There, as you have documented so well, David, there was a lot of activity here on the East Coast in semiconductors before the West Coast lit up. And so Raytheon was one of the stars here. And I got the guy's name and called him up, and what a delightful human being. His name was Norm Krim, and I've documented his work in a number of ways. I had the pleasure of knowing him for a number of years. And what a story. And I think that really ignited my interest. He graduated from MIT in the teens, became the VP of their vacuum tube business, sub-mini vacuum tubes, and took over the hearing aid market, and had the foresight in the late 40s and early 50s to take Raytheon from a leadership position in small tubes to the premier transistor manufacturer in the world. What a guy. And what a genius he was to do that, and it just all kind of rubbed off on me, and I was just fascinated by his stories. And he was a roommate with Shockley for a while. He started the first large-scale production for germanium transistors. Krim did, all for hearing aids, and that just fascinated me, and that really kind of launched my. I didn't know what a difference between germanium and silicon was at this discussion, or how this all fit into the great scheme of things. I was just fascinated by it.
So it was more the personality and the drive that he exhibited, which is what I find so fascinating about interviewing pioneers of the business. It's what motivated them? Where did they come from? Why did they go in this direction? And what were the things that led them there? So your introduction to the pursuit of early semiconductor history is through Raytheon, Norm Krim, and the 722 device.
That's correct. And that path, I can show you one if you want, a CK722, but that path was, you can imagine what the yield was for these devices, these first alloy junction transistors in epoxy, close to zero. And there was some testing that was done in these production. The production was 10 miles away. They ultimately moved it to Maine. But barrels and barrels of these things, these little small black plastic transistors, worked okay. I mean, they had some transistor action, but they weren't sufficient to meet the requirements for hearing aids, where you need a certain gain and certain noise factors. So according to Norm and some of his engineering staff, somewhere here, maybe it should be a hazardous waste dump, I don't know, there are these big barrels of thousands of these transistors that they couldn't get rid of. And so Krim said, you know what? He was a hobbyist as well, and so he would cause those devices that still worked, but didn't meet specs for hearing aids. He met with the editors for a number of the hobbyist publications, radio electronic news, electronics, all that, and started passing these things out by the tens, by the hundreds. And all of a sudden, in the mid-50s, you would see these articles being published saying, use your CK722 as a code practice oscillator, or build a CK722 as a radio. And those were rejects, fallouts from the hearing aid line, and there was a big fat stamp that said CK22, and he marketed those things. And they sold by the millions, and it's amazing.
So Raytheon was selling them as their product. Yeah, it wasn't an
Correct.
Independent business. Okay, fascinating. And so you wrote about this, or published a book or something, was there?
I have several things. That article in IEEE Spectrum was about him, and that got lots of publicity. My website at the time went from a few hundred to many thousands of hits after that was published. I've written a book on the CK722, self-published, and I've done a number of interviews, oral histories, with Krim and others who were involved at that. It turns out companies following in that path figured out they too could take fallouts from production, relabel them, and sell them as, hobbyist devices. So GE did the same thing. I talked to their lead designer. Sylvania did the same thing. I talked to their lead designer and got oral histories from that. Western Electric didn't do that. Either it worked or it didn't. They had really high manufacturing. So there are no fallouts that were sold from Western Electric, but nonetheless, that opened up a whole avenue of focusing on early germanium transistors and how they were manufactured and what the problems were.
Interesting. I just have a little aside here. One of my early jobs at Fairchild was similarly finding a way to use stuff that was not saleable as normal product. And we came across the Hong Kong transistor radio manufacturers who were making these 6 transistor radios, and they all decided to make 12 transistor radios. They soldered 6 more dead devices onto the boards that were connected to nothing, but it was wonderful for their advertising.
That was a huge business, and you and I have to connect on this because I've moved from the 50s and germanium transistors into the 60s, and you know we've talked back and forth. I'd like to do some similar work with globtops, and thank you for educating me that was a real term. And so I have maybe the world's largest collection of 1960s fallout globtops in my museum right now, and they all have various histories.
Fascinating. Tell me, so there's 2 aspects to the museum. There's your physical collection, and then there's everything you put online. How is organized is the right word? How did you go about structuring your online museum, and what are the key aspects of it?
Yeah, you know, I have thousands of pages, and they started back in '96. So it's been an evolution. I've restructured a couple of times. And I need to go, I'm concerned that that stuff's going to get lost, or I get comments all the time from visitors to the website saying, what a fascinating story that you've told. I could spend hours here, which is good. I like it. But, you know, this was built with late 90s web technology, and I've just added on to it. And so I'm concerned that it's going to get lost, going to get hacked. And I'm pondering now, when I do get more time to spend on this, to try to take advantage of, what year is this? 2021 technology for the website. And I'm not quite sure how to do it. One of my goals is to make this more easily accessible. I don't have any social media presence. And I know that's really important. There was no social media. There was U.S. mail back in the 90s, right? Yeah. So.
And AOL.
Well, that almost counts, I guess, huh? Yeah, so I'm at a turning point now where I'm trying to figure out, I don't like spending a lot of time on the infrastructure. I really want to focus on the content. But I feel as though I need to take a pause. I'm looking, for instance, at, I don't know what the term is, perpetual storage or forever storage or something. I would like this work to be available somewhere in the cloud because, you know, in my opinion, there's, just like with the oral histories that you do for CHM, there's really important information in there that I just don't want to get lost. And I'm using Yahoo Business now as a website. It's been okay, but I'd like to have some more confidence that either through Google or some other hosting organization, this stuff could be saved. I am on a mission now to do both those things, come up with a better way to organize and store this. And also I'm looking to, I have thousands of different types of devices in different quantities that I would like to have each one of those documented and remembered. And so I'm looking for maybe a short 1 or 2 page format with a picture and an actual device that people could get or use as a way of preserving, you know, this
Well,
history.
you have produced a number of kits in this fashion, Jack, and you've very generously provided a number of those to the museum for our collection. Are they available online? Are they things that people can buy?
They are. And so thank you for mentioning that, yes. And so I'm doing, you know, kind of the old school way of making these available. These are loss leaders. I don't make any money on this, but I provide, you know, documentation about why this device is important, and I provide the device. And I think that reaches a certain audience, but I'm just trying to, I don't want to have boxes and boxes of stuff, right, in 10 years. I'd really like to distribute this as much as possible, and I appreciate what CHM has done with taking some of the rarest devices. That's really been helpful to me. And I'm trying to find some other way to make this to kind of preserve this memory. So it may be all virtual in the end, and the actual physical devices, I don't know how to handle with that yet.
Does your wife and kids have opinions as to what you should do with all this?
Well, they're all very helpful. I'm not in the mode of having too many boxes that could cause structural damage to the house, thank goodness. I've evolved beyond that, but I do have external storage where much of the stuff is kept.
Okay.
And I got to tell you, David, some of this stuff is just heartbreaking. Many of these devices are some of the first transistors ever designed, and they're truly historic. And I remember one case a year and a half ago, a woman called me up saying that she was going to an estate sale, and there were 2 boxes of electronics, and she was going to pitch them out. And she happened to see my website and call me over. These are some of the first devices made at Western Electric, 1952. Unbelievable. This stuff cannot be gotten any other way. So I was able to recognize it, and I gave her a fair price for it, but how many times has it happened that stuff goes to the landfill? It just breaks my heart.
What is your favorite area of the museum? Which topics or which devices or eras?
Well, I've taken several approaches. One is oral histories. I think that's my favorite part. So I have several hundred of those. And I just have really enjoyed talking with the engineers and the scientists that were involved in the mostly 50s. That most of them have now passed, unfortunately. So I had pretty good access in the late 90s. But just being able, everybody was totally generous to a fault, wanted to share their, well, you know how it is. People really want to help people understand what it was like a long time ago and what the challenges were and how they overcame those and their successes. So I think that's probably the most important part. And I again, struggling with this because there are dozens that I should have followed up on that I didn't. And I just haven't had the time to do that. And that's probably the area that I would most like to focus on.
Is there perhaps one device that you really would have loved to have got a piece of and talked to the inventor, and something that made a difference in the world from your perspective?
Good question. I think it's both the device and the application for the device. I did have a chance to talk to the Bell Labs, this may be my favorite, the Bell Labs engineer who built the first transistorized circuit that was not experimental. Walter Mcwilliams, I did his website. He was living in he had retired, and I got a chance to interview him personally. He built a matrix for gunnery control, trajectory control, that had been tube-based, and he used some of the first experimental point contact transistors in a matrix to do an XY coordinate system. And I have pictures of it, and I have some of the transistors, and I have his description of what it was like to follow Shockley around, or Bardeen or Bretan, and get some of those first devices, because he was a young guy at the time. So I think he documented this. This is the first non-experimental, non-developmental application. It was used in the military. So that got my attention. That one I like a lot. And so that opened up the whole area of not just the devices, but also interesting applications. So, first hearing aids. Some of those first ones were hybrid with small tubes and transistors. That's an area of interest. Radios, medical devices, and currently I'm looking at satellites and spacecraft, which for obvious reasons had a real need for small, lightweight, low-power devices. So I think that's my primary focus now, is on spacecraft, and I am talking to some designers from the 60s for some of the first spacecraft, and that was my other kind of, I got in on the ground floor of that first couple of satellites, Vanguard and Explorer, got a chance to talk to the folks involved in that.
And of course, Raytheon had a major role in building the Apollo mission equipment.
Yeah, and I'm looking forward to moving into the 60s, David. That would be my next goal.
Okay. Is there someone that you really want to interview that you just not got hold of yet, but is still around?
Yes, I think. So one of the areas of interest to me is, as I said, applications for early transistors. And so one of those applications is in music. And so I was not able to interview Robert Moog. I was not able to do that in the time when I should have with the synthesizer. He used some of the first germanium and unijunction silicon transistors, and he has many articles. But there are a couple of folks who did early instrument design, some of the first guitar amplifiers transistorized, and that's an area I'm trying to get into. And so there are a couple of founders of electronics companies that are available, and I won't go into any further, but that's one of my current paths.
Yeah, there's a whole branch of technology there that now is a huge consumer of semiconductors.
Right. So I think I'm going to try to, if I can figure out how to update the website from 1990s technology and something that I can do in a reasonable amount of time, I'd like to branch out with more oral histories. I think that's kind of my goal.
Any other goals for the museum? Where would you, when you're no longer here, Jack, what would you like to happen to?
Yeah, I'm struggling. You know, along that line, over the years, I've made friends, I'll call them friends, I've met most of them, who are kind of unofficial semiconductor, either collectors or historians. They write, they have websites. And so I'm not unique in that regard, meaning there are world-class collections of semiconductors that, you know, half a dozen or a dozen or more individuals have put together. What's going to happen to that stuff? And unless there's a kind of a concerted effort, I know what's going to happen to it. And so I don't know exactly how to address that, but I don't think I'm quite alone. Thank goodness for the CHM, you guys have been kind enough to take some of the items and have them available, and I know they're in a good home.
And our
but I have a
focus
few
is
thousand
very
more.
specifically in that area, but you've covered a much bigger area than we can possibly stretch out into. Have you explored the Smithsonian or what their possible interest might be or ability to manage this?
I have not really. I have gone to their website and see that they have quite a bit of semiconductors, and so that's a possibility. I don't know what their policy is, how that works. Do you work with them at all? Does CHM work with Smithsonian?
Not directly. We have worked with them on some specific projects where they've been looking for some information, but and DAG may have more information in that area too in terms of who might be interested. But you have a huge collection of electronic documents, interviews, and all these other people that you talk about. Might be some way to knit this together in an overarching manner to make sure it's at least all stored and accessible somewhere.
Yeah, that would be a good goal, I think. I'm still trying to figure out how to get myself up to that task. That seems like a pretty good, commendable thing to do. And if I may be so bold, I know you've done such a phenomenal job with wrangling all the various documentation and people and histories, you know, and I would like to emulate some of that if possible. I need to get some more time and focus is what I need.
You got the content. It's a matter of figuring out how to make it available. How would you interest kids these days in what you're doing? Why should a kid care about a CK722?
Really good question, and I've been struggling with that one as well. I don't know, to be honest with you, who the interest group would be. It's something it's going to evolve over time. So, for example, I'm not sure what interest level there is, and this would be. I'm trying to think about this as a possible analog for coin collecting or stamp collecting, for example. Right, where there's a specific model or type, case structure that could be, it's really close in application, where there are different semiconductors from the past 70 years, and if they could be made available in an inexpensive way, which I could do, and also in a compelling way, why not? Why not collect semiconductors? I don't think there's a big market for that now, but there could be. What do you think?
Well, it's the story, as you said many times, it's the stories of the people and why it was important. And somehow if you connect a kid to a personality or something that they can relate to, maybe music is the way. That's certainly it's a long way from your rock and roll music of the 1960s to what we listen to today, but there's some kind of a connection there.
Yeah, maybe it's TikTok. Who knows? Maybe TikTok is the way to do it, huh?
Sure.
I would say this. The Smithsonian's an interesting approach. I'll have to think about that. One of the gentlemen, I had a few visits at my house, which is where my virtual museum is, from some of the folks who were really proactive in the 50s. And one of them, a guy named Bob Slade, great guy, was the first transistor engineer at RCA. And he was a prolific writer. And he was responsible for the first RCA transistors. And I had some of them. And he came by and we chatted. What a pleasure. Turns out the Smithsonian had one on display. And he did not know that. And so once that was discovered, he made a trip to the Smithsonian and got his picture taken next to, I'm sure it was the device that he personally had handled. It was a point contact device. That was one of the most rewarding interactions I had. That was, I really liked that.
Looking forward, we talked quite a lot about kids. What kind of advice would you give a young person, male or female, who's wanting to get involved in electronics business these days?
Boy, that's a hard one. I try to put myself in, in the place of somebody looking to be involved in technology. I don't know, David. What do you think? Is hardware the place to be, or is it software? What do you think about that?
Well, software is clearly what's controlling just about everybody's lives today, but it's the silicon and other technologies behind that makes it all possible. Are there still going to be people who are making these chips 10 years from now, or is it all going to be designed by computers and AI that determine what the designs are? And what role can a young person have in helping control and create that? I don't have answers to the question. I'm intrigued to know. Everybody sits at a keyboard today.
Yeah.
Few people go into a lab and have to probe a chip and find out what's broken.
Yeah. So I don't know what that means either. I don't have an answer for it, whether it's a good thing or a bad thing. But it's the way it is, I think. There's some phenomenal work being done on the internet now with, I would say, engineers, probably middle-aged engineers who still have a bent on hardware, so they decapitate chips and do a detailed analysis. I was just looking recently, some gentleman recreated the 555 timer, the most, with vacuum tubes. Have you seen that?
I've heard of it. I'm not familiar with it.
Unbelievable.
You have to ask why, but you shouldn't.
That's right. I mean, that is, in my opinion, that's incredibly cool. That is so cool.
And there's similar replications of the Intel 4004 early integrated circuits and work that's been done there.
It's incredible to me. And
intellectual exercise is what it is.
Yeah. And so the fact that there's enough time for people who are really smart and who can do that level of construction. That's amazing to me. I'd like to tap into that, but I'm not sure how that fits to a single poor performing alloy junction germanium transistor that only works on Thursdays. I'm not sure. One thing, it's probably possible to do a 3D print of a transistor now. I'm thinking, certainly you could do the case, but I'm thinking it's possible to do the junction as well. So
there were many
intriguing
attempts at that in the early days, particularly at RCA, to try to print transistors. The issues are always a matter of the control and variability of materials, I think. But then you'll look at what it takes, a multi-billion-dollar factory covering 10 city blocks, just to hold the equivalent of a projection aligner to make transistors, to make integrated circuits. Essentially, there are dozens and dozens and dozens of layers in these things, so they are being printed in that sense.
Yeah. Do you mind if I ask you a question, since
Sure.
we're here? I'm totally intrigued and fascinated by those artistic, large statues of the Fairchild Mesa, the 2 in 697, and the Shockley 4-layer diode.
Yes.
Can you tell me anything about the story of how that came about?
Developer Malone Grier, I think it was, in San Diego, bought the whole block that included the old Shockley building, which is, 916. It's on San Antonio Avenue in Mountain View. I'm sure you
Right.
drove past it many times.
I did, yeah.
And there was a strong movement not to knock down the Shockley building because of its historic. But that lost, but part of the deal with the developer was that they would invest, I think, about $250,000 in various kinds of artwork to document what went on there. And that was the basis for it. There are 2 IEEE milestone plaques that we placed there, one for Shockley Semiconductor Lab and one for Moore's Law. And each of those are associated with these artworks. The Moore's Law has a 20-foot high silicon molecule representation standing behind it. The transistors out on San Antonio Avenue were one of the proposals by artists in response to a request put up by the developer to create sculptures to record this. So that they were funded by the developer as part of being able to knock down the Shockley building, I guess is the summary. I did have quite a conversation with the artists. If you look closely, the leads are bent. They thought that was a nice artistic touch. And I said, but those parts would have been rejected by any manufacturer that you shipped them to back in the 60s.
Yes, indeed. So still impressive. And I don't know why that came to mind. A lot of those early Fairchild devices are artistic anyway, with the stylized F stamped in the top of the case and the various, there's art, there's real art there as well in that process.
Yeah, so that's the story behind I forget the name of the plaza, Technology Plaza, I think they call it. And there's a disk drive road and a semiconductor drive in there. And at least it is a place now where the history is recorded and people can go to physically and look and touch something which relates to what went on there all those years ago.
Yeah. Well, good for that whole effort. That clearly was a fundamental milestone in semiconductor history.
Sure. Well, Jack, it's been fun talking to you. Any message you'd like to leave for people who are going to watch this 200 years from now and wonder what Jack Ward was doing in his basement in April 2021?
Yeah. I just, in life, you can never do everything that you want to do. I'm being a little philosophical here. But, in my particular case, and there are others, trying to get a handle on changing technology and the impact it had on me personally, and how I'm documenting that, and how I'm hopefully making some contribution that allows it to be around for a while. you know, I know I'm not alone, and this doesn't apply just to semiconductors. People get attached to stuff that was impactful to them, you know, and want to try to do some kind of contribution, I guess, to keep it living. That's what I'm doing. So if you ever get bored, spend hours at transistormuseum.com and help me as I transition to a more perpetual storage and more ease of access. That's the message, David, I'd like to get across.
Well, thank you for your time today, Jack. It's been delightful to catch up on your background and understand a little more about what motivated you and what keeps you working to preserve this history. So thank you for joining us, and hope to see you on the West Coast again when such things are once more possible.
Thank you very much, David. I appreciate you taking this path. I'm hoping that we could in person collaborate at some point, because I don't know, there's a lot of stuff that you also have brought to bear, and I know you've been interviewed, but I'd like to take that path as well at some point.
Okay. Well, it's been fun, Jack. All the best to you.
Thank you.